Alright, so we're back with another number systems video and another video on implementing a conversion method into C. This time we're going to be dealing with decimal numbers to hexadecimal numbers, or hex for short. So let's just get started on what hexadecimal exactly is. Throughout this video, I'm going to be just calling it hex because it sounds cooler and it's the shorter name for hexadecimal. So let's get right into it. So the key difference between the decimal number system and the hexadecimal number system is that the decimal number system works as a base 10 system. So I think a good example would be the number 37. For you to get the number 37, or put those two numbers together, the first digit, you have an option to express the number 7 either through the values of 0 through 9. And to express the number 3 in 37, you have the option to express that value between 0 and 9. For 0 to 9, that amount of options that you basically have to express the number 37, or each digit of the number 37, it's 10 options. Hence, decimal is base 10 system. With hexadecimal, well, hex means 6, and decimal, in this case, as we put right here, means 10. So this is just going to be 6 plus 10. A base of 6 plus 10 is, well, a base of 16. So the difference between decimal and hexadecimal is that hexadecimal is a base 16 numbering system, and this is going to be very important to keep in mind when we do our conversions. This is because when we want to convert from a decimal number to a hexadecimal number, we're going to have to know the exact conversions that go from decimal to hexadecimal by making this kind of chart here. So we have our decimal to hex chart that we're going to make here. So the value of 0 in the decimal number system will be the same. It's going to be 0. The value of 1 is going to be 1. The value of 2 is going to be 2. The value of 3 is going to be 3. I don't want to be very redundant, I'll be honest, but you get the point. It's the same all the way up to the value of 9. So for the next 10, 11, 12, 13, 14, and 15, instead of having Arabic numerals, which is 0 through 9, the regular numbers, you could say, instead of having any of these numbers represent our values of 10, 11, 12, 13, 14, and 15 from our decimal system, we're going to actually just replace them with our English Latin alphabet. 10 is going to be assigned to A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So now let's actually get on to the actual math part. So similarly, when we convert a decimal number to a binary number, we're going to have to deal with a form of successive division, but this time we're going to be doing successive division with the number being divided by 16, since we're dealing with a base 16 system. And similarly, like converting from a decimal number to a binary number, we're going to also have to pull the remainders from the divisions that occur, and those remainders are what's going to ultimately allow us to convert that decimal number into our hex number. So let's put an example. Let's just do 829 as our n value in this chart. So we're going to put 829 here. Now what we're going to want to do is we want to take n, which in this case is 829, we want to divide that by 16 and pull the remainder from it in this third column of this chart. So let's go ahead and do that. So 829 divided by 16 is going to give us 51.8125. When we were converting a decimal number into a binary value, because the remainders were always going to be either ones or zeros, since we were dividing that number by 2, it was pretty easy to kind of just take all the remainders that we got and read them from most significant bit to least significant bit, and then that was our binary value. But in this case, we're going to have to try something different in order to pull our remainders. And it's not too difficult. All we're going to do is we're going to take our value of 16 and we're going to multiply it by 0.8125 to get our remainder value over here. So let's go ahead and do that. We're going to do 16 times 0.8125. And that is going to give us a remainder of 13. Now, similarly, like we were doing successive division in our last video, the new n value is going to be the whole value that we got from dividing n and 16, which is going to be 51 in this case. So our new n value will be assigned to 51. So then we do 51 divided by 16, and that's going to give us a value of 3.1875. And if we multiply 16 by 0.1875 right here to get our remainder, so we're going to do 0.1875 times 16, and we get a remainder value of 3 right here. Finally, we reassign n to the value of 3, and then we do 3 divided by 16, which is going to give us 0.1875, and once again 16 times 0.1875 is going to give us a value of 3. And once n is assigned to the value of 0, the successive division stops. So we are done here. So now we have our remainder values right here, and we have our very beautiful, not so beautiful, decimal to hex chart that we will be referencing when we make our final conversion. Similarly, again, to when we convert a decimal number to binary value, we want to read from the most significant digit, which is going to be the last remainder that we pulled, and we're going to read it all the way up to the top, to our least significant digit. In the case of binary, it was most significant bit and least significant bit. In this case, it's going to be most significant digit and least significant digit. So we have our remainders, 3, 3, and 13. And when we read it from this way, we can refer to our chart over here to give us our final conversion of the number 829. So 829 converted to hex, we can just look for 3, which is going to be 3. We can look for this value, which is going to be 3. And finally, we can look for 13, which is going to be D. So our final hex value for the number 829 is going to be 33D. Alright, so we're going to create a program in C which we can take a decimal number and convert it into a hex number. So like I did in the last video, I like kind of building the skeleton of the function that we're going to be programming, which is going to be our decimal to hex function here. It takes one parameter, which will be the number that we are wishing to convert here. And what the function is going to do is basically just print out the converted. It's going to print out the hex value of the decimal number that we want to input. So in this case, n will be our decimal number here. So let's just get started on how we want to implement this conversion process here. So before we really hop in and start coding, we have to think about the fact that since hex not only deals with Arabic numerals of 0 through 9, the standard, integers, but it also deals with letters, in particular from letters A to F. And because of that, we can't just use any kind of integer variable to do this, unlike when we were converting from decimal to binary, in which we could use an integer array to express our result, since literally binary is only ones and zeros. So in this case, both of these variables that we are declaring are going to have to be char variables. Char variables are just short for character, and a char variable is basically just one character, and a collection, an array of char characters, is a string. So basically, we're building a string in this program. We want to establish a variable that will iterate through the indexes of the result variable that we create. And at each index, the iterative variable is able to update that index with whatever is stored in the iterative variable. Kind of like in the last video where we iterated through the integer array, updated each index with the remainder of the successive divisions that occurred, we're going to have to update our result variable, which, as I've been telling you, is going to be a character. And a character variable can be treated as an array, especially when allocated a number of elements to it, which we will do. So we're going to establish a char variable called ch, and we're going to also put another char variable, which we'll call result, and we're going to allocate 50 elements to this char character. So basically, once we do this line, think of this variable as being an array of characters and has 50 elements to it. I'm just allocating 50 elements to this character array for the purpose of this video, since we're not really going to be taking that big of a number to convert. We're just going to use 829 as a decimal number that we will be converting. The next thing that we're going to want to do is create the loop that is going to do our successive divisions and also pull the remainders from those successive divisions until n is assigned to the value of 0, which is how successive division works. We keep on dividing over and over and over and pulling the remainders until the value is 0 and we can no longer divide. Let's start by creating an incrementer variable for this case. So we're going to do I equals 0, and our incrementer variable will be very crucial for traversing through the index. And once we are able to traverse through the index through the incrementer variable, then we will be able to have our iterative variable of ch update that very index in the result array with whatever is in this variable. So let's create our while loop. So we're going to do n is greater than 0 so that it stops at 0. So let's create a variable that will be assigned to the remainder of the successive divisions that we do. So we're going to do int rem is going to equal to n modulus 16, since we are dealing with the base 16 system. And so since we now have our variable, which is rem, our remainder, we are now going to check if the remainder is less than 10. So before we even code this in, let's talk about what happens when the remainder is from the values of 0 to 9, aka less than 10. If the value of the remainder is from 0 to 9, then nothing really happens to the remainder value. It's just going to stay the same. However, if we get a remainder variable that is 10 or greater, then we're going to have to assign that remainder to either the letters A or F, because this is, again, we want to convert to the hexes base 16 format. So if rem is less than 10, we're going to assign the char variable of ch, which is the very variable that when we iterate through our result array, we'll update each index with whatever is in here. We're going to update this variable with the remainder plus the character 0. What this line does, it might look confusing because you might think, how exactly are we adding a int type value to a character? Now, the ASCII value of when 0 is a character, as you see here, designated by the apostrophes, it's going to have an ASCII value of 48, which, if you aren't familiar with ASCII values, I would suggest you just pop in a little Google search, since I'm not going to go too much into this video about it. But essentially what this line of code is going to do, this is going to have a result of the remainder, but turned into a char type. And so what that means is that our ch variable is going to be assigned to whatever the remainder is here, but as a char type instead of an int type. And that is exactly what we need if we want to build our char, aka character array, aka our string. So that is what this line of code does. Now for our else statement. Our else statement is going to deal with cases where the remainder is 10 or larger. And if that is the case, then we're going to have to deal with the letters A through F. We're going to assign our ch variable with the remainder plus A minus 10. In these cases, remember that the remainder variable is going to be 10 or greater. And so when that is the case, we're basically going to deal with 10 or higher minus this 10. When we add this to our character of A, it has an ASCII value of 65. So basically, let's say our remainder variable was assigned to the int value of 10. This would be 10 plus 65 minus 10. And what this line of code is basically going to do, since it is adhering to the hexadecimal format, is it will turn whatever the remainder is into the letter that corresponds with its remainder. So with 10, it would be A. With 11, it would be B, and so on and so forth. What you really have to remember with these lines is that this will basically retain the remainder value from 0 to 9, but we'll put it as a char type, and this will not retain the original integer remainder value, but it will turn that value into a char type representing from either letters A or F. So now we're gonna store the character in our result array that we got from here or here. So we're just going to do result I, which is going to be our incrementer. At the first iteration, it will be at index 0, and then first, second, third, however many iterations need to happen, however many successive divisions need to happen, that will be the index getting updated, in which that index will be assigned to whatever is in our ch variable. After that, for preparation of the next iteration, we need to set up our new n value that will be divided by 16. So we're just going to assign the value of n to n divided by 16. And then finally, to top it all off, and for I to increment every single time the loop happens so that we can iterate through every single index of our result character array, we will do I++. After all the successive divisions and iterations are done, we now have to add a null terminator to our result, since we're dealing with a string, an array of characters, and we need to designate where our string ends. Our string ends at whatever I is the value of, because it took I amount of iterations to build our string within our character array. So what we're going to do is we're going to do result I, and we're going to assign that index, our end index, to our null terminator. Now we want to reverse the result string, which is the string, the character array that we have stored all of our remainders and converted remainders in, and print out that final answer. So the reason why we are reversing our result string, if we take a look at the chart that we made, when we were doing our successive division, each iteration of our divisions that we were doing, the first iteration division that we did gave us our least significant digit, while the last iteration of division that we did gave us our most significant digit. And since we read our values from our most significant digit to our least significant digit, that means that we're going to have to reverse what we put in our array. Because if you think about it, the remainder column that we created when we were solving through the division is the same exact thing that our code is doing in this entire while loop. But since we're humans, we can read a chart, from bottom to top. Code can't do that. So we have to tell it to read from the back to the front. So to do that, we're going to create a decrement variable that starts all the way at the end of our character array and moves backwards all the way towards the beginning of that array. Print out all the values from the back to the front, and that will be our final result. So to do that, we're going to do for int j, we're going to assign that to I minus 1, which is going to be the length of our character array but in indexes. The loop will terminate when j is greater than or equal to 0, and each time the loop progresses, the j value will decrement by 1 in j minus minus. And then all we have to do from here is we want to print all the characters from the end to the beginning, from the most significant digit to the least significant digit. So we're going to do print f, we're going to catch the characters, and we're going to let it print out the result at index j. And just like that, we have constructed the very function to convert a decimal number to a hex value. So let's test this. So we're going to create a variable called decimal, that's an int. This will be our user input. We're going to ask the user for input, so enter a non-negative integer. And then finally, we're going to scan that input, catch it, and assign it to our decimal variable. And then finally, we're gonna call the function decimal to hex, so dec to hex, and then our variable decimal. So let's test this code. Right, we're gonna try our number 829, and there you go, we get our value 33D, which is exactly what we got on our chart. So that's going to be it for this video. This is the code that is going to convert a decimal to a hex value. And I hope you guys enjoyed this video and learned something from it. FYI, please let me know if you are a better C programmer than me, because I'm pretty sure 99% of the world is. But let me know if I explain these lines correctly, because as I was learning this, it was a little confusing. But yeah, I hope you guys enjoyed this video, and thank you guys for watching, and I'll see you in the next video.